Okay, so I kind of wanted to review the question from quiz one, or sorry, quiz number 8. All right, so we had the system of equations with an R and an S, and I wanted to figure out when it had no solutions, exactly one solutions, and infinitely many solutions. All right, now when you look at this, and R is again variable, so what is going to happen is if you see here, as you rotate or just play with R, right, those lines change. And if you notice what's happening here, these are all the instances where we have exactly one solution, right? But at some point, right, we get something where it looks something like this, and it looks like we have no solutions, right, where it doesn't seem to intersect. All right, and then at some point here, it looks like it completely overlaps, and we have infinite number of solutions. So I would like to find out what happens in terms of R and S in that case. Okay, so let me switch over here. Okay, so if I switch over here to the quiz, so as I gave as a hint to look at the augmented matrix, so that looks something like this. All right, and if you do twice row 1 added to row 2, you'll get something like this. Now, once we're here, we're in the reduced echelon form or row echelon form. So we have 0 here, and then I'm left with these parameters here. So I'd like to know when there is no solution, right? So I'll start with A. And how does that happen? Okay, so as it turns out, to get no solution, that means that down here we'd have to have, so there's some number, 0, 0, and some number here that is not 0. So in order for no solution to happen, I would like to have this to be equal to 0. Right, so that means R is going to be 5/2. Right, but I also have to make the stipulation that S cannot equal to -6. All right, because this has to be non-zero. All right, so this is the case where we are in A for no solution. All right. All right, now for the next one, where we have exactly 1, right, so in this case, looking at what I have above here, I'd have to have number, 0, and also here I'd have to have some number and just any other number here. Okay, and this could be 0 or non-zero. It really doesn't matter as long as I have a number there, which means that in order to have exactly one solution, right, I need R to not be equal to 5/2. Right, and S could be any real number. Right, in that case, I would fall in this case. Now, the last one, where we have infinitely many. Okay, now that's going to happen where I have number, 0, 0, 0. Okay, so in that case, I need from above here, R has to be 5/2. But now, and I need to have S to be equal to -6. Right? And when I have that, that would correspond to infinitely many solutions. Right? And that is how you do problem number 1.